Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
From the Hindu scripture, the Bhagavad Gita, Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
LFG chat, welcome to the live stream, guys. I'm your host, Ashton Forbes, and we talk about science, guys. Today, we are talking about quantum entanglement, and we're talking about the physics of being ratioed. But before we get into that, guys, TGIF, I hope you're having a wonderful Friday, everybody in the chat. One thing I want to talk about before we start talking about the science today is this idea of whistleblowers. Now, we don't talk about the UFO community that often, but sometimes we do. And I want to express my opinion about the UFO whistleblowers. People like Matt Brown. I'm using him as a direct example. Matt Brown, my understanding of the whistleblowers like Matt Brown is they come from an intelligence background. They are intelligence analysts, and they have seen something, potentially in surveillance, that has led them to believe that there is exotic technology and aliens on this earth. Are we all in agreement that that's the current understanding of people like David Grush as well as Matt Brown? Because that's my understanding of their situation. Now, why this is important is that what do these people really know? Like, if I'm a magician and I show you a trick, you're only seeing what I want you to see. And you're making your mind up based on what I've shown you. So what concerns me is this, just to be perfectly clear about this. What concerns me about the whistleblowers is that they saw something unusual and they came out and said, "Oh, there's aliens on this planet. There's no way that can be humans, what I just saw." But is that really true? Is that really true? How would they know if that's not just some advanced project with the military that they saw? And they get asked this question all the time. Everybody asks them this question, and they always say, "Well, I would know if that was human technology. It doesn't look like any human technology." This is the big problem. This is the reason why the MH370 videos are so important. The MH370 videos show that, no, you would not recognize it. You would not recognize human technology. Because these videos, they give you enough context that you can tell that what you're seeing here is United States hardware, United States surveillance, United States covert operation, and United States weapons. That's the reason why if an intelligence analyst were to see this, without any context, like imagine there's no Boeing 777 there. Imagine there's no Boeing 777 in this video. You would say, "Oh, it's just aliens are flying around in their orbs," right? That's what you would assume, because you would say there's no way that they can have orb technology. But when you watch this video of literally the missing airliner, Malaysian Airlines Flight 370, this isn't a joke or a scam. That's literally the missing Malaysian airliner. Let me point something out real quick too. When people try to say this is a hoax video, you can see the air conditioning exhaust manifolds. There's 6 of them where the air is a different temperature because of the air conditioning. Presumably it's hotter because there's hot smoke circulating throughout the air conditioning. You can see it because of the temperature difference. You think somebody faked that? They have to be a Boeing engineer to know to fake that. Okay, I get aside the point. My concern is that I think some of these whistleblowers, they're putting the cart before the horse. They're putting the cart before the horse, and they're saying, I'm whistleblowing on illegal operations, illegal alien technology or reverse engineering technology. But what if it's just not illegal at all? What if it's not illegal, and what if it's not aliens? Then the whole perspective of these whistleblowers gets flipped 180 degrees. Because what the MH370 video shows, like somebody said, like Edgewood says in the chat, that's an illegal operation. I would agree with you. I would say whatever happened to MH370, that was an illegal operation. But here's the reality of it. There's no way it was illegal. They had the legal backing of that. And this is the scary part, is that most people look at the MH370 videos and they would go, okay, if that's real, that's illegal. And B, that means we've got alien technology. That's what most people would say. But what if the truth is it's not illegal and it's technology that the United States has developed? Whether or not we developed it from aliens or whatever, you're never going to be able to prove that. For all intents and purposes, it's just human technology. Humans are using it, right? And you say, yes, it's very advanced, but is it illegal to have very advanced technology? No. There's no laws saying, hey, it's illegal to have free energy technology. And you would say, well, it's illegal to do a black operation. Is it? Is it illegal to do a black operation? I don't think that it is. That's the whole point of our CIA. It's literally the whole thing they do is like 15 major black operations per year. So obviously they're not illegal. They're doing them. They have some justification. So this is what I would tell you guys, to be careful about these whistleblowers. What do they actually know? What are their direct claims that they've seen with their own eyes? Have they seen aliens before? Or are they just hearing secondhand stories and putting the pieces together in their mind? Because it's a big, big difference. And here's the last point. If I'm right, and these whistleblowers are seeing advanced government technology that's being protected for national security reasons because of the Invention Secrecy Act, Atomic Secrecy Act, then nothing is ever going to come out of them being whistleblowers. Nothing will ever come out of it, because you would say, well, we give them amnesty. Give them amnesty for what? You haven't even defined what it is they're allowed to say. Give them amnesty for leaking nuclear secrets? That's never going to fly. So what are we giving them amnesty for? They don't even know what they're looking at. And this is the craziest part. A lot of them just admit they don't even know what it is. They'll say, I don't know what it is. If you don't know what it is, why are you asking for amnesty? You don't even know if it's illegal or not. So just to rehash, there's a really good possibility that this alien technology stuff is completely legal. Whether or not you agree with it morally or not, I happen to disagree with it morally. But we're going to find out, I think, that it's totally legal. And that means all this amnesty and whistleblowers amounts to nothing. It amounts to nothing. Because determining whether or not something's legal is not an opinion. I wish it was, but it's not. And the CIA, guarantee you guys, is they have their legal justifications wrapped up. They have it wrapped up. We're not going to agree with them, but they have it wrapped up. Okay. Now, this takes me into my next point, guys. The science of ratioing people. This might be the most important science that I've ever taught somebody, because it actually comes into play every single day. And a lot of people don't know what ratioing people is. So it turns out we have a great example. Turns out the last few days I've been in a little mini feud with University of California, San Diego professor Brian Keating. Now, the UFO community hates this guy, and he rage baits them all the time. That's fine. I don't care about any of that. I just want to talk about physics. Unfortunately, we find that instead, I get AI responses. I get YouTube video links from fake professors that just pretend they've never actually taught anybody before. So let's go ahead and show real quick, explain a little bit of the science of ratioing people and what it means. So it's a very serious discipline, guys. Oh, well, this is just a cool video that I just wanted to show you anyway. It doesn't have anything to do with ratioing people, but this is literally plasma. This is plasma compression right here. Hold on, let me make this bigger. Here you go, chat. Is it going widescreen? I can't tell if it's working or not. Hold on. Let me move this over here. Okay, yeah, there we go. So this is almost exactly like what the orbs and the MH370 videos are doing. So you have these cylinders here, right? These magnetic cylinders, and they compress the plasma between them due to the electromagnetic field that they produce. So you can imagine either a series of rings, or you can imagine a cylinder at the center of it. And now these would force your jets either direction. And then the plasma bubble would form around the rings, entirely around the rings, and you get your plasma bubble. So there you go. This is just a dope video. That's all. Nothing too special about that. Okay, so check out, make sure you guys follow Skocatic Scribe. He's dope. I like his stuff. Okay, now here we go. The science of ratioing. Here you go, guys. This is also the science of rage baiting right here. All right, so this is where it all started. UFO true believers aren't just wrong. They've built a techno cargo cult around fake physics. As somebody who spent 20 years building experiments to test the actual laws of nature, here's why anti-gravity craft is pseudoscience wrapped in Pentagon PowerPoints. Jesus. This is like Sean Carroll saying that we'll never warp drive in the Casimir effect is real, but it can't ever do anything. Quantum mechanics can't ever do anything. We'll never get a warp drive, right? Like that. This is the equivalent of that. So what is a ratio, chat? What is a ratio? When we ask what a ratio is on Twitter, what we are looking at is the mathematical equivalence between the number of replies and or number of likes related to the total number of views that a post has relative to another reply related to that post. Ashton's theorem, chat. Ashton's theorem, the expert on ratioing. Now, look at these numbers. Let's take a look at these numbers. Guys, I want to go ahead and enhance this as well. Let's go ahead. Bob, can you go ahead and enhance that for us, please, good sir? Yeah, I need an enhancement of that I was just showing right there. Okay. Where is it? Oh, yeah. Okay, here it is. Okay. There it is. Okay. Okay, let's enhance this, please. Enhance. There we go. There we go. Okay. Enhance. So you can see here, we can count the numbers. We have 465 replies relative to 700 likes. Even though this post over here, if you see 270,000 views. Now, at first glance, you may say, how do I interpret these numbers, Ashton? How do I get meaning out of E digits? Well, first, what you want to know is the number of replies related to the number of likes. When a post has a significant percentage of replies divided by likes, that means generally it may be rage baiting people, or maybe upsetting people, and maybe engagement farming. Now, also, if you take the number of likes divided by the total impressions, this gives you the likability index. How likable was this post? Now, 700 likes may seem like a lot, but when you have 270,000 views, likability index is quite low, quite low. Now, another thing that you can compare is you say, not only for the post, judging the post itself, but what about the replies? What about the replies? So Ashton Forbes, Just X Ashton, came in. He said, gravity manipulation is real. It's a consequence of Einstein's relativity. He's the one that predicted gravitational waves. You know that guy that you bow down to all the time? He's the one that said space isn't an empty vacuum. He's the one that predicted gravitational waves. G-forces don't matter when you manipulate the medium because space is not empty. So let's see what this reply got. So this reply only had 26 replies and yet 800 likes. Now, this is very important because now if we apply the ratio mathematics, we can see that the number of likes related to replies significantly lower on the reply ratio, but huge amounts of likes. And Now we can include another factor here. We can take this same math and we can apply another function to it. We can say, what is the ratio of likes to impressions on the original post? If we go up here, 700 to 270,000, and compare it to the likes and the views of the top reply. And what do we see? 800 likes and only 47,000 views. That's 5 times less impressions than the original post. 5 times less. And yet more likes. Yet more likes. What does this math equal? This equals you got ratioed, bitch. You got your ass ratioed. Oh, there's more examples. There's more examples. So that's called the original post ratioing. Now, I have a few other quick examples that I want to show as well, because there's a few more. Now, that's just an original ratio that happened to Professor Brian Keating here. I think people didn't really care for his post. Now, here was his follow-up post. Now, this was him trying to ratio me, chat. This was him trying to ratio me. He was doing his best here. He said, I'm going to ratio this guy. So I said, I put out this long drawn argument. You guys can read through it, or you can check out the live stream from Wednesday. And I said, I was very respectful. I said, I don't think you don't understand my argument. Look at this. Only 140,000 views. That's less than his had, but it has 1.5 thousand likes. I have twice the number of likes as his post with almost half of the total engagement. Once again, the ratio index tells us here that my posts are more likable than Brian Keating's. And then here you go. You can see that even in sub replies, he's being ratioed. Even in normal sub replies, he's being ratioed here. You can see that the total number of impressions way lower, yet look at the likes. Now, I tried to be nice, chat. I tried to be nice, but what did we get in response? What did we get for our being nice? What did Professor Keating give us? Here it is. He gave us AI slop, chat. He gave us AI slop. Instead of giving us a coherent response from an actual human being, he said, Grok, tell me how I should reply to Ashton Forbes. And then Grok spit out some bullshit. You can tell this right here in the beginning is the dead giveaway. So all you AI people out there, you want to go edit your AI post, you got to get rid of the double hyphen. Nobody uses this. It's not a thing anybody ever uses, guys. So when you use the double hyphen, we know right away you're using AI. You got outed, son. You got outed as using AI. So he got some AI. Now let's see how this went, right? So we can see our ratio up here. We have a very normal, healthy ratio. How did the AI slop do, chat? Oh, it's looking bad, chat. So now we can see the full-on reply ratio in effect. We can see the reply ratio in effect here. We can see there's 93 replies with only 80 likes. 80 likes out of 112,000 views. Brutal, chat. Brutal. It hurts me in the inside a little bit to see this happen to people. I don't know if you can come back from a serving this deep, but maybe he'll find a way. He's a physicist. I think he can find a way, guys. And then one last example. So when they've been ratioed all to hell, the last desperate gamble is for them to find a YouTube video that's defamatory, that's incorrect, and just post it. And post it. It says, Ashton Forbes is a grifting fraud. This must prove that Ashton is wrong. And the worst part is they don't even watch the videos themselves, chat. They don't even watch them themselves. So usually my response is something like this. Which point did you think that he made that I need to address? I find it very interesting when people link videos and they don't make any arguments. Then when they get pressed, they say, watch the video. Did you even watch the video? Or did you just read the title? This reminds me exactly of Danny Jones when Danny Jones made his title about healthcare consultant gets debunked or whatever it was, and everybody's expected to be, and then they watch it and they go, oh, that's not what it was at all. So in his video, how did this one do? We're getting worse and worse, chat. We're getting worse and worse. Now we have 25 replies, 6 likes, 26,000 views. 26,000. That's getting ratioed by every means possible. So the mathematics doesn't lie, chat. All you have to do is take the number of likes or the number of replies divided by the likes, or the likes divided by the number of impressions, or in some cases, the third identity, the number of likes on an original post divided by the number of likes on the top reply. Okay, guys, that's enough fun. Okay, guys, the next thing I want to jump into is the meat and the bones of tonight. Oh, wait. I'm not done. I have a video. Chat, we have a video. What do you think this is? You think I'm just some nerd that just talks about stuff? No, we do videos here. Videos are twice as fast as information, maybe
principle thing called the Casimir effect, and hopefully a little bit about black holes as well.
Whoa, Casimir effect and black holes? Yeah, tell me,
So I guess
bro.
we have to start with the basic physics, which is the uncertainty principle. It's this weird thing that you can't measure the position and the momentum of a particle at the same time. And actually for this video, the important one is...
Oh, spoiler, if this gets me copyright striked, I'm going to have to delete this part. So I just skip ahead if so.
You can't measure the time of something and the energy of something at exactly the same time. So if you've got a photon, you can measure exactly when it arrives if you want, but then you don't know what its energy is, or you can measure exactly what its energy is, but then you don't know exactly what time it arrives. And there's a fundamental uncertainty in that energy, which works even if the photon has zero energy. So if the photon fundamentally has sort of zero energy, then there's an uncertainty that actually you can't tell whether it's zero energy. It could actually have some energy.
So you guys probably can guess where this is going. When someone starts with quantum mechanics and they're like, man, we can't measure anything. We can measure the energy, but we can't measure its position. We can't figure any of this stuff out. But when we start to do the math on all this, what's going to start happening, chat? Anybody know out there? Can you guess based on the context of what's about to occur here? We're talking about 0 point energy.
So that means that a photon with zero energy isn't there at all, basically. You've got nothing there. And that means that even when there's nothing there, you can actually have a photon with suddenly acquiring an energy. And that leads to this weird effect that even in the vacuum of space, you can have photons popping into existence for a brief period of time. So basically, you can sort of cheat nature. You can borrow energy as long as you put it back before anyone notices. And that's this trade-off between the amount of energy you've got and the amount of time you've got. And the more energy you borrow, the less time you can borrow it for.
This is pretty crazy because this right there, when he says borrowing energy, you can borrow this energy as long as you put it back. Because now we're looking at the universe in a different way. We're not looking at the universe where we're producing something and now it exists. We're saying you can take something, but you got to give it back. There's got to be an equivalent exchange always. This is what Charles Chase was talking about at his APE conference. All the crew, they were talking about, yes, you can take something, but you got to pay it back. But when and how are you paying it back? And if that's true, what are we? What are we? Because we come from the ether too. Everything comes from the ether. So how is it that we are out here coherent, not part of the ether? How are we not just absorbed into the equilibrium? Why are we talking here? Why do we have intelligence? Why can we do all of these things? That's just something for you to think about.
And that means that the vacuum of space is actually this seething mass of particles and antiparticles being created. There are some rules so that you have to kind of create particles in pairs. But beyond that, even in the vacuum of space, you can have particles popping into existence and disappearing again. So this idea that vacuum is empty is actually not correct, right? That even in vacuum you have...
Hold up, chat. Hold up. Wait, we have sound effects now? Where are the sound effects? I think we have sound. Oh, we do. Oh, no, I didn't add them yet. Oh, God. Okay, well, we'll just play this. Okay, yes. He just said this idea that space is empty is not correct. So, Professor Keating, knock, knock. Ashton's home. It's time to apologize. Hold up. I got something for you, sir. Professor Keating, this is for you, homie. I got it all filled out for you. Ready to go. Space is not an empty vacuum. Here you go. To Ashton from Professor Keating. Look, there's your beautiful face. Reasons for behavior. Number 1, I didn't understand physics. Sorry, them's the facts. Number 2, listen to YouTubers. Never do that. Debunkers lie to you. Number 3, never trust the government. Never, ever trust the government. They will lie to you about physics. They will lie to you about technology. They will lie to you about black projects. And then, of course, jealous of Ashton. Everybody's jealous of Ashton. I don't know why, but it is what it is. Oh, and then the final point, Ashton was right. I'm a retard. There it is. Go ahead. You can take that one for free. I filled it out for you already ahead of time. I feel like we're going to have many more of those coming up in the future.
Virtual particles.
Just in case we missed it, let me just go back here.
So this idea that vacuum is empty is kind of is actually not correct, right? That even in vacuum you have these virtual particles that appear and disappear. So it applies to every particle, absolutely anything. You know, so I was talking initially about photons, but you can do it with electrons and positrons appearing. You can have protons and antiprotons. You can have anything you want, but obviously the more massive the particle is, remember from Einstein's famous equation, E equals mc squared, the more massive the particle is, the more energy you're borrowing to create it. And therefore the quicker you have to put it back before anyone notices. So the least massive particles can exist for the longest periods of time.
You couldn't create like a planet.
So that's pretty cool. So the least massive particles can theoretically exist for the longest periods of time. Although we're pretty massive particles, if you would ask anyone out there, and we live for like 100 years. Well, not quite, but like 75. In the future, we might live forever. So I definitely think that when we are looking at this, like we're looking at this 0 point energy that exists everywhere. And by the way, I'm skipping through a little bit of that, but the next part he says, if you do the math on this 0 point energy, if you start saying, okay, there's this energy, there's these virtual photons, and we can rip them out and they can become real photons. He says, if you start doing the math on this, the energy density is infinite. Infinite. Infinite energy density. Infinite energy density. So what is the energy density of the 0 point energy? It's potentially infinite. And the only reason why some people don't think it's infinite, the people that understand 0 point energy, is because they think that it might cut off at the Planck scale, which is a very small wavelength. If it cuts off at that level, then it's not quite infinite. It's just this huge, 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 huge amount. Okay. So we have this 0 point energy, this infinite energy, and light, photons. Photons are electromagnetic energy. Photons are the point-like representation of an electromagnetic wave. Okay? So this connects to the idea of the ether, because now we're saying that we're in a medium of energy and we can pull that energy out. We can rip that energy out of this medium and it becomes light as we see it. Eventually it has to get paid back at some point, but we're not too worried about that at this point. Now, the thing that left Einstein perplexed was spooky action at a distance. Quantum entanglement. Quantum entanglement was the thing that shattered classical physics. Because up until that point, we were just thinking, okay, sure, there's this Heisenberg uncertainty principle. Sure, we have Schrodinger's equations, but end of the day, we don't see any of that. End of the day, when we're walking around in our reality, we see causality. Everything makes sense that we see. We don't see these quantum things where the pendulum never stops swinging. But is that true? Is that true? No, it's not. We see things like superfluidity, superconductivity. We see things like quantum tunneling. We can even see macroscopic quantum tunneling in the form of light. So quantum effects are very, very real. The scientific paper I'm going to show you that we're going to take a look at through here, the second half of this live stream, basically proves that classical physics is wrong. Because classical physics cannot explain how we can have an object over here, information over here, transmit over here faster than the speed of light. Faster than the speed of light would allow. So if this distance between my two fingers is 100 million miles or something like that, just making up a number, right? We can see action interaction between these two things, like this one goes this way, this one goes this way, right? Or vice versa, whatever. Any of this? We can see that happen faster than what should be possible, even at the speed of light. And we've tested this. It's called the faster than, I don't actually know what they call them, but the faster than light records or whatever for quantum teleportation. This is what they're talking about. How far can you teleport information? And then they measure the time. And then they can figure out, oh, well, that was moving faster than the speed of light. Okay. So this opened the door to something called quantum entanglement, quantum teleportation. We call it EPR. EPR. Einstein, Podolsky, Rosen. That's half of ER equals EPR. Now, this idea that these two things that are separated by extreme distance can be connected somehow, this cannot be explained from classical physics view. From a classical physics view, everything must be connected, or these must be little particles, and there's no way this particle over here and this particle over here can interact. It's not possible. So to test these experiments, people have been building EPR experiment devices for decades to test quantum entanglement, to try to understand how can this quantum entanglement work and why, and if we push it to its limits, what can we learn about it? If you haven't watched the live stream, I recommend going back and checking out the non-locality live stream where I review the dirt about non-locality and John Kramer's view, because that paper actually has basically all the significant EPR experiments up until about 2010. Up until about 2010. The experiment that we're going to look at here tonight is brand new. This experiment, this scientific paper is from 2025. And this scientific paper even references the old EPR experiments. Actually, it references the quantum eraser experiment. So the last thing I'm going to say before we watch this video is, what is the quantum eraser experiment? I'm going to tell you conceptually what they did. So these entanglement experiments, they shoot light into a crystal and they have it split. When it splits, they're entangled. And now, which way did it go? We can't tell. So what they do is they do a measurement. After it splits, they'll do a measurement that causes the wave function to collapse. But then what they can do is they can rebuild the wave function. You're like, wait, what? What do you mean rebuild the wave function? Basically, they send one of those photons through a randomizer. Shoot it through a randomizer. Shoot it through a randomizer. Now it could be in any one of three locations. And now there's no way to tell. That's how they rebuild the wave function. And then what happens is we can infer which path the photon goes down based on looking at its entangled pair. What? Yes. Pay attention. I'm going to say it again just so you track this. We take a photon, shoot it through a crystal. The crystal shoots it into two. These two photons are now entangled. One of them goes straight to a detector. Boom. The other one goes through a randomizer. Boom, boom, boom. And then we say, okay, there's no way you can tell which of those three things it went through. It's random, right? And we say, nope, I can look at this one over here, and I can infer based on where this one hit, I can infer which of those three it was most likely to go through. And if you give me like 10 photons or like 60 or 100 photons that starts to form a pattern, I can tell you exactly which path it went down. And the craziest part is this. On the randomizer path, you can change the distance. So wait, why is that important? Well, okay, we have our control path that tells us where we think the thing's going to end up. Well, if we change the distance of our randomizer path, then technically the detector path has already hit before the photon even gets to the randomizer. Let me repeat that again. We can see the detection of the photon before its entangled pair even gets to the randomizer. So before its entangled pair even gets to the randomizer, we already know which of the three paths it's going to go down. Retrocausality. Exactly. That's the quantum eraser experiment. Okay, so now I've just explained to you the quantum eraser experiment. If anybody doubts that I understand quantum mechanics, just play that clip for them. I'll be happy for somebody to explain it better than me. I would love for them to be able to explain it better than me. So now this experiment that we're going to look at here takes it even further. Takes it even further. So most of these experiments are like, you know, splitting a light beam between a crystal and then trying to do this weird stuff to figure out like, okay, we can change the path, you know, trying to tell the future type stuff, right? Trying to tell the future. So here is Sabine Hassenfelder explaining this effect. So she actually reviewed this video the other day. I watched it and I was pretty impressed, not necessarily by her explanation, but by the paper itself. So let's show this. Here you go. Credit to Sabine Hassenfelder. I don't know if she needs our shout out, but there you go. Hold on.
But their setup takes some explaining. You see it here. You see they have 4 of these stations. These are materials that have the property that if you shine on them with a laser, then sometimes they'll emit a pair of photons. And then they have 2 measurement stations, one for the photons that come from these 2 emitters and one from those that come from the other 2. What they do then is that they either shine a laser on these 2, which creates 4 photons, 2 on each side, or they do it with the second 2. They do this so that from the photons alone, it's impossible to tell which pair of emitters they came from. In each measurement station, they then measure the interference between the 2 photons after a phase shift. The important point is that this measurement is a Bell test. It's an indicator for whether the photons left and right were entangled. They shouldn't be, because there's only entanglement on each side, not between the sides. Yet, what they find...
Okay, so what did she just say there? She said, this is a Bell test. Okay, go check out Bell's inequality theorem. Bell test basically says, does classic physics allow this to happen? Does classic physics allow this to be explained? If you are violating Bell's theorem, whatever, then you are saying that classic physics falls apart. And what did she just explain about this apparatus, about this configuration? At a high level, what she's saying is we have two separate entanglement systems. 2 separate entanglement systems. And then what we're going to do is we're going to join them. We're going to have 2 paths join. Okay? We're going to get 2 separate entanglement systems. And then we're going to have one path, one option where they can cross over. The streams can cross. What do you guys think is going to happen? What do you guys think is going to happen where we're going to go ahead and we're going to split one photon over here. And then over here, we're going to split another photon. We're going to split 2 of them, and then we're going to shoot them around in different directions. And for one path on each side, we're going to have them be able to come together. So that now there's a link between the 2 different entangled sets. What's going to occur? I'll tell you what I think is going to occur. I think, actually, you know what? I don't want to tell you. I'm going to show you what I think is going to occur. Is this it?
Law of thermodynamics tells us that...
Oops, that's not it, chat. Hold on, here we go. This is what's going to occur.
Second law of thermodynamics.
Oh, chat, 3rd time's a charm. 3rd time's a charm. When you click the wrong one, feels bad. Here you go.
This is an audience in Budapest applauding after a performance. But what happens now?
Oh, wait.
They're not being instructed by anyone. See if you can spot the phase transition.
That's what's going to happen, isn't it? Isn't that what's going to happen? Once you link them together, even though it should be impossible, we've got 2 entangled sets that are both non-local. And if we just put a connection between them, they're going to synchronize together, aren't they? Well, let's see what happens. Oops.
Is that the 2 sides are entangled. The authors don't know why, really. They just speculate that it's got to do with the fact that in their setting, one can't find out the origin of the photons from the measurement. They are now doing further tests. New Scientist has lined up a few experts who have some ideas about what might be going on. Stefano Paesani says the issue might be the post-selection. What he means is that these emitters don't always fire 2 photons when they should. The authors therefore only use the data for cases when they actually have 4 photons. It's possible that something went wrong there, but I think it's a fairly standard thing. Jeff Lundin.
Okay, the first debunk is ridiculous. The first debunk is like, they cheated. They just cheated and only somehow did measurements when entanglement wasn't happening or something like that. Like, this is just like, what are these explanations? What's the next one?
Thinks one can get entanglement without entanglement, but that it just doesn't mean anything. I don't think so. And then there is Ephraim Steinberg, who thinks there's still some entanglement in this experiment. Indeed, that was my...
Okay, so we've got answers from, they just did the math wrong. They did everything wrong, and they calculated wrong. Then we've just got people saying, it doesn't mean anything. It's real, but it doesn't mean anything. This reminds me of like some of the PhDs they talked to. It's like, yes, the Casimir effect is real, but it doesn't mean anything. What the hell are you talking about? It doesn't mean anything. Literally, we're seeing entanglement where there should be no entanglement whatsoever. That means something for sure. In fact, I think it means something very deep about our universe. Very deep about our universe. Now, instead of just listening to other people talk about it, let's just show the scientific paper, because I read through it, actually. And I can actually understand a significant amount of this. Scary. Scary, chat. Violation of Bell's inequality with unentangled photons. So basically, they say that the math shows that they're outside of 4 standard deviations here. So this 4 standard deviations is basically saying, unless they did something significantly wrong, what they're showing here is mathematically accurate. The experiments hold up. There's no way you can say this is an error due to rounding or, some BS like that. Violation of local realism by Bell inequality, a profound and counterintuitive manifestation of quantum theory that conflicts with prediction of local realism, is viewed to be intimately linked with quantum entanglement. Now, that is one hell of a first sentence. It's basically saying the reason why things are not real, they are not physical particles, is because quantum entanglement shows us this is the case. Now, what did I want to show here? I probably should have took some screenshots here. Oh, okay. Now, I think I know what I'm going to do. I'm going to just show the graphs. Where are the graphs at? Here they are. Here's the graphs. Okay. So I read through this, and I tried to explain it. Can I enhance? Let's enhance. By the way, there's nobody else here. I'm just saying that because it's funny. Okay. So when we look at this graph, the one that we want to look at is the B, the one on the right. The one on the right over here, okay? Now, the one on the right, if you look at P1 and P2, these are our 2 different entanglement setups. P1 and P2 on the right. They are shooting our photon. That's our pump photon going into the system. The crystal is this non-linear crystal you see in the middle, this rectangle you see in the middle of it. What's going to happen now is the light is either going to shoot right through the crystal, it's going to go right through the crystal, or it's going to become 2 entangled pairs. It's going to become 2 entangled pairs, okay? So it's either going to go right through the crystal, or it's going to split up into 2. One of those 2 things is going to happen. They're using a non-linear medium, non-linear crystal medium. Now, if it goes right through, it's going to hit a mirror. So watch the purple line. Purple line goes right through, hits the mirror, it's going to bounce back. So when it bounces back, it's going to do it again. So same thing happens in P2. There's a mirror, it bounces back. Now, if it creates the 2 entangled photons, then you're going to see it reflect. It's going to reflect off of it, and it's going to go to one of our detectors, A1 or A2. Okay, great, right? This all makes sense. Same thing is on the other side here. Or actually, maybe I have those directions wrong. Sorry. It's not going to reflect. It's going to go through and it's going to come out at an angle. It's going to go through and come out at an angle. So P1 will go through, come out at an angle at S1 and I1. Okay. And then P2 will come out at an angle at I2 and S2. And then if it goes right through, it hits the mirror, comes back. And then in any of these situations, you can see they're just bouncing off of mirrors here. So look down at the bottom right where you see M1 and M2. Those are mirrors. So if you create an entangled photon, Then it's going to run and hit the mirror, and it's going to bounce back into the optical medium. So in almost all these situations, it's hitting a mirror. So we have it hit this optical medium. It comes through the other side, shoots out 2 directions, and then it bounces back into the optical medium again. Okay. So what are we doing? We're basically just bouncing light away around off of mirrors. Now, what else is interesting about this setup? How about that it's symmetrical? The system is symmetrical. So we have a symmetrical system of mirrors, which means what? Technically, this light is bouncing back to its origin, right? Everything is canceling out. If I were to take light beam going this way, light beam going this way, you're going to have destructive interference, right? It's going to cancel out. So the setup of this design is really interesting because everything should be canceling out if you watch this. Like, if you look at it, it's all perfectly symmetrical. The light beams are all interfering with themselves, interacting with one another, and going through this optical medium. But then what do we have going on in this bottom right? In the bottom right over here, you see this parallel path. One of the sets of the mirrors links them together. So one of the paths links the two different entangled systems together. You can see that path down on the bottom right over there. Now, what's interesting about this path is that this path makes it so that you cannot ever tell where the original photon came from. You cannot ever tell where it came from. In fact, now that we've understood this, let's read what the paper's explanation is for this. Okay. I'm not going to read through what I just literally explained to you here, but this is basic idea. Now, I also think that when you go back to this experiment, they mention here, oh yes, you can move M1 and M2. M1 and M2, the mirrors, that's how you change the distance. So remember, when I told you about the quantum eraser a second ago, I said one is our default path, goes this way. The other one goes through a randomizer, and then we can change the distance before it gets to the randomizer. This is also true of the mirror here. Now, what are we changing when we change the mirror? If we take this M1 and M2, those mirrors, if we pull the mirror away or forward, we have the Doppler effect happening. So let's say I have a light beam hitting this mirror, right? What happens if I pull the mirror away from it? Uh-oh, we have to stretch out further and further. This is going to change the phase. So you can actually change the phase alpha and beta. Hopefully that's the phase, right? Alpha and beta. I think that's the phase. So we can change the distance. We can change the measurement settings by controlling the phase. Oh, Ashton is so good. Chat there. It says it right there. Change the measurement settings by controlling the phase alpha and beta, which basically just means change. Oh, I was not showing that. Just means change the distance from the mirror. Okay. So this is important because this is how we're going to do our measurement. This is how we're going to tell that the two systems are entangled. We're going to manipulate one of those and we're going to see what happens. We're going to manipulate those mirrors and we're going to see what occurs. So it says, initially, the two photons from the sources in our experiment are entangled in momentum and frequency. We then destroy their momentum entanglement using single-mode fiber coupling, which performs strong predictive measurements on the momentum of the photons. Using bandpass filters, we also destroy the frequency entanglement between them. Therefore, we cannot use these internal entangled DF in the Bell inequality test presented below. So what they're saying here is that they make sure that the wave function has collapsed. They make sure the wave function is collapsed, and then they're going to rebuild the wave function. How are they rebuilding the wave function? Through that connection between the two of them. The connection between the two of them is what's rebuilding the wave function, because now that's the equivalent of the randomizer. Now you've said, okay, you could be in this system, but you might also be in this other system as well. You could be in either system. To be honest with you guys, this paper is amazing. There's not a lot of papers I read where I go, man, this might win a Nobel Prize. Like, if this actually is real and they can give us some more additional experiments and evidence, like, you know, why would this not? Okay, so they show you a whole bunch of math here, blah, blah, blah. Here's a whole bunch of math. We established a connection between our experimental configuration and the inequality through the joint probability distribution. So they show these equations here. The correlation between the 4 photon coincidence. What do you notice about this? They're perfectly in phase. Now they're not actually, that's not the right way I should put it. They're not perfectly in phase. They are correlated in phase. Their phase is correlated. And what they say is when you do the statistical analysis, this correlation is 4 standard deviations away from the mean. 4 standard deviations away from the mean basically means this is not accident. There's no way it can be an accident. This must be because these two systems are somehow talking to each other. They're somehow talking to each other. You know what's crazy when I watch this? I'm actually getting goosebumps looking at this. This is exactly what the pattern is of the orbs in the MH370 video. Perfect sinusoidal pattern. But there's 3 of them, not 2. You have 3 phase patterns spinning around the plane just like this. Do you know why that's important? Because the MH370 video orbs are entangled. They've created entanglement between those 3 orbs. Because the question we should be asking from this experiment, what even is entanglement? What if I can entangle 2 systems that were not previously entangled? What is entanglement at all? What does it even mean? How are we making it? And now we realize it might be something much simpler. If you put 2 systems, if 2 systems are exchanging information with one another, they become entangled, instantly entangled. Maybe there's more to it, but that's what this experiment tells me. This experiment that we're looking at here tells us we can entangle 2 separate systems together that have no entanglement between them. And why is that important? Because we don't need coincidence entanglement for that. Coincidence entanglement is me shooting my light beam into the crystal and then it's splitting off. And so we know what the source was. We know the source of that entanglement. The source of that entanglement is when I shot the photon into the crystal. What's the source of the entanglement when 2 different beams of light are just sharing a path? What's the source of entanglement there? Big question. Now, to be honest with you guys, if we're struggling with this, if you're struggling to comprehend this, well, don't feel bad. Literally the smartest physicists in the world struggle with this. You just heard 3 physicists weigh in on this, and their answers were, it doesn't matter. Maybe they messed up. And then the third one is, well, maybe there's still entanglement there, which doesn't even make sense. So those are PhD physicists, presumably, having no logical explanation whatsoever. So if you are out there and you're coming up with explanations and you feel bad because you think, oh, I might sound dumb, well, you can't sound dumber than those guys. So there you go, chat. Now, it says here, the correlation functions of Alice and Bob, and also they use Alice and Bob. All the teleportation experiments also use Alice and Bob. Also, I want to tell you guys something else as well, which is that when I first saw those leaked BASS documents that came out a few months ago, I saw them like over a year and a half ago. When I first saw those, I also saw some scientific papers about teleportation. And the first thing that blew me away was I was looking at EPR experiments. I could tell right away because it was all about, you know, the photon going through a splitter and having entanglement happen. So these EPR experiments, like that was part of the reason why I knew early on ER equals EPR, even before I understood the significance. Now I know for sure Einstein-Rosen wormhole is equivalent to quantum entanglement. They are fundamentally the same. That's why we're seeing Alice and Bob get talked about here, because we are literally talking about teleportation. We're talking about teleportation of information. And then right here, we can see this correlation function. The correlation function between the 2 alpha and beta, the 2 phases, the correlation is nearly perfect. They are nearly perfectly correlated. That would mean that if one thing happens to one, something's going to happen to the other. So they've actually taken these 2 separate entangled systems and they've correlated and entangled them together. They were able to produce entanglement at will. They produced entanglement right there, which is amazing because now apply this to the MH370 videos. You got 3 orbs spinning around your plane over here. How do we get this plane? How do we get this plane over here? Well, we have some orbs over here, or one orb over here, and it's sending messages. It's sending a message to the orbs over here. It's sending a message. They're communicating the same way those two paths are communicating. The two paths, as we saw, they're connected by a bridge. And then they become entangled. And now whatever happens to one correlates to the other. So what's happening with the orbs around the plane? They are correlated to another orb or 3 other orbs somewhere else. Ashton, 6 orbs. Thank you very much, Z Jalapeno. Appreciate you. And then what happens when the orbs encapsulate the plane, when the plasma creates a sphere on the plane, now we've tricked the universe. Now we've put the plane in superposition. We've now said the plane can be anywhere. It can be anywhere. Or more realistically, it can be over here or it can be over here. And we do a measurement and we find it over here. What we've done is teleported the airplane. Now you may say, Ashton, that's crazy. Well, guess what? This paper is crazy as hell, chat. Because the next thing this paper says, I think if we go to the conclusions, it discusses it. Conceptually, rather than merely measuring an entangled quantum state, we actively manipulate the state during its creation. Our experimental setup enables this manipulation to show quantum correlations that violate the Bell's inequality. And then it says certain things about, people are going to say that maybe this doesn't work. And they say, one could argue that there's a created of a multi-photon superposition between the 2 photon sources. It says, however, this is incorrect. As long as the photon paths are superimposed, the which path information never exists and hence need not be erased, which is the fundamental difference between this work compared to all quantum eraser type works. Now, this part I thought was interesting because it references a quantum eraser right there. But I think what it's saying here is that because all the paths cancel out, because there's not like we go down this way and this, this distance versus this path over here is like completely different. It's got a randomizer in it. They're saying because both paths are perfectly symmetrical, everything cancels out. So if everything cancels out, you have a system that's in superposition. You have a system where I can't tell if this thing shot it or this thing shot it. I can't tell if the photon is here or the photon is here. It could be in either position. Well, wait a minute. Isn't that what I just said about the plane? Yes, it is. Yes, it is. This is why quantum mechanics is so incredible. Because we can actually see these quantum mechanical effects on the macro scale. This experiment is a macro scale experiment that we can see these effects happen. So how do we scale this up? Well, the thing that people need to remember is scale invariance. Scale invariance. People tell me electromagnetism and gravity can't be related. Gravity is too weak. They have the exact same form. This means the only difference between them is the constant. This means that one is weak, one is strong, but they are perfectly linear in their relationship. So what this means is if we can scale something up, now you can see the difference between gravity and electromagnetism. Because what's big is the same as what's small. What's small is the same as what's big. A sun can be miniaturized. We're basically just zooming out. And yes, as other people point out in the chat, it's fractal. That's what fractal means. Fractal basically means scale invariant. The same shapes you see on the small scale are the same shapes you'll see on the large scale. I think there might be one more thing. What else did I want to say? I'm just looking to see if there's any more thing. So yeah, I think that's pretty much what I want to say on this. So this experiment takes the EPR to the next level. The reason why I think this experiment is so significant is because we've been looking, a lot of people have been asking me, and even asking me today. They were saying, where are they at now? We saw these videos from 2014. 2014, what are they working on now? Well, we don't know what they have in the black projects right now, but we can see the science that's out there publicly. And this science out here is getting us closer and closer to the actual physical macroscopic teleportation, because it's showing us that classic physics is wrong. Space is definitely not empty, and we're not dealing with real little particles flying around everywhere. It's much weirder than that. And quantum entanglement is not just a rounding error or a mistake. Quantum entanglement is a real physical property that must be taken into account in any view of the universe. Must include that. Okay, guys, we're going to do a shorter live stream tonight, guys. That's going to be the bulk of it. I hope you guys have a good week, and I hope you guys have a great weekend. I'm going to be doing a couple things to try to beef up the content, including a second camera and some other stuff that I got hooked up. Let me do some of these donos here, and I'll answer any other questions for the last few minutes. Guys, thank you very much, Matt. Matt asked in the pill chat, do you think Russia, India, and other people have or know about this technology? Yes, I think the other countries know about it. But look at how far advanced we are right here. Like even this live stream, we're talking about the most advanced quantum entanglement EPR experiments that are publicly available. Everybody's trying to figure out teleportation. They're trying to figure out how to manipulate the ether. And China's trying to figure it out as well. How far are they? Hard to say. What I am confident about is the United States is way ahead of everybody else. United States is way ahead of everybody else, but other people are going to catch up, and they're going to catch up very quickly. Like within the next 5-10 years, maybe sooner. Okay, sweet. And then let's see if we got anything here. Yeah, Herb Green, thank you very much, man, in the Rumble chat. Appreciate you guys. Timothy Foster, thank you very much for this donation. Appreciate you. Mick Leonard, thank you very much. I've recognized you, Mick Leonard, in the stream for a long time. Thank you very much. And for all the other longtime viewers, especially the ones who maybe you haven't done a lot of super chats, I understand. I want to appreciate you as well. We are the change. Thank you very much. You've been in there for a long time as well. Leslie Wisdom drops a 20 into the brains. Hurt Fifi's tin cup. Thank you very much, everybody. Hurt Fifi's gets a 20. Appreciate it, guys. We're going to get some brisket after this. Sam Fisher says, random question that might have been asked a long time ago. Do you think Russia and China obtained the technology for the orbs? That's funny. This is basically the same question as before. Oh, through the solar wind hacks? No. I don't think they got it through the solar wind hack. I think that all of these countries are spying on each other. They're all spying on each other. They're trying to infiltrate each other's black projects probably all the time. So I think they all know about like electromagnetism and, being linked to gravity. The question is, what can you build with it? What can you engineer with it? And the number of people that know about this is obviously growing, especially now that we've built this 0-point energy community, MH370X. The number of people that can do this stuff is tiny. So another thing that I see mentioned a lot, I saw somebody posting this in the chat earlier saying, why aren't people building this? Why aren't you building this? Why aren't you actually building something? Why aren't you building something? Why aren't you doing it? It turns out building stuff is really, really hard. It's really, really expensive, and it's really prone to error. This is part of the reason why it's been so successful. There's not a magic bullet to make this go away. It's just the way of the world. The number of people that can produce this stuff is tiny, and the number of people that know about it is also tiny, and the number of people that have the resources and want to spend their whole life doing it while instead of doing a normal job is also tiny. Multiply these factors together, and you get a vanishingly small number of people. I do not have time, money, or any of those things to do that. I mean, I have a normal job, guys. So that's the point about how to do it and why it's been so tough for even countries to figure this out. But once they do, it's going to get crazy, guys. Okay. A few more donos. Atlantean Priest King. I'm going to take some shit and Chris Mellon can pay it back. Chris Mellon, man, the Mellon family, nobody can convince me that these people have not been profiting off of this knowledge and technology. Now, you may say, well, maybe they don't deserve to be punished because he's been trying to get it out there. But has he? Has he really been trying to get it out there? How many of these people have just outright said, yep, we've got super advanced technology that will change the world? Very few of them. The ones that do, I give them lots of props. Most of them just say, we got to hide stuff for national security, but aliens are real, guys. But aliens are real. Not interested in that. Zapparoo, thank you very much for those super chats. Camera Money, thank you very much. Appreciate you. And then Mayo says, cheers. Jazz hands, chat. And then Chaotic Good says, do it, lady. Now let's take a look and see if there's any. You guys have any questions that are non-super chat questions? I'll do 1 or 2 non-super chat questions. Put them in there right now, guys, while we wind down. If you have any other last questions for Ashton Forbes. And let me see what else I got for you, actually, while we take a look at that. I think we talked about everything I want to talk about. Oh, there's a Greer video as well. Okay, we do have one more video we're going to show. Where's Lulu? Lulu was chilling over there, but she bounced. She's on the bed now, I think. Okay, we're going to show one more video. So nobody has any questions, guys. Fine. What's up with Dave Rossi? What's up, indeed? Dave Rossi kind of went dark. He kind of went dark. He hasn't really told me exactly. I mean, he hasn't really. I think he's got a Patreon and stuff like that he does, what have you. But we still text periodically. I was actually thinking about, you guys think I should invite Dave Rossi back on the podcast? What do you guys think? Maybe. What's your next step for the show? We're going to be talking to Salvatore Pais on September 7th. September 7th. I think he wants to do it live. He likes to do them live. So we're probably going to talk to Salvatore Pais next on that front. And then I don't know if I know UAP Gerb. I don't know if I know him, but I've seen him going around the scene lately. So maybe I'll check him out. And then I still want to do some content that is video recorded content, but I just like live streaming, chat. I just like live stream. It's easier for me to get motivated doing live streams than it is for me to like go make some pre-produced content, edit it, do all that work. I'm just kind of lazy on that front. Where is the Stephen Greer thing? Crap, I had this up. Hold on, I think it's in here somewhere. Oh, I think it was, hold on. Here it is. This is it, I think. Oh, it was on Red Pandas. Okay, sorry, guys. One sec. Okay, actually, you know what? I'm not even going to show the Greer thing. So basically, Stephen Greer was saying that, you know, the same reason why they can't get this information out, you know, related to it is that nobody's going to take the risk of putting themselves out there when they're just going to get attacked and discredited and what have you. And that's kind of what I was just saying as well about why these engineers, why, you know, why do people ask, why doesn't it leak? Well, it does leak, but these people, they're very well compensated. Like the people that are doing this are like millionaires, right? At a minimum. And if they have patents, then they're making even more than that. So they're living very comfortable lives. And so what Stephen Greer says is you need several different things. You need the knowledge, you need the character, and you need the integrity. I don't know if that's exactly correct, but that's the idea. You need the integrity. You need to be able to say, you know what? I'm going to risk it all, and I'm going to put it all out there. A lot of these whistleblowers are not doing that. They're not doing that, right? They're saying, okay, I'll tell you what the government tells me I can say. And that's the reason why we're not really getting anything done. We need some of these people, the Hal Puthoffs, the Eric Davises, the Charles Chases. We need them to step up and just say, look, man, free energy is real. They've been building plasma technology. It's way beyond what the public understands, and it looks like aliens, right? We need that to happen. And we're not going to be able to just make a lab and be like, yeah, outsource it, make the schematics available for everybody. Have Joe Schmo the redneck go and produce the supplies for us. That ain't going to work, guys. I wish that was the option, but now we've hit the level of metamaterials and microchips, and the technology now has got to the point where you need actual material manufacturing to pull it off. That's the problem. So there's not going to be any doing it live. There's not going to be any, live streams of making the free energy devices. I wish that was possible. And I wish we could be like, hey, here's the schematic to go build your own, free energy device with, and have like the resources and the supply chain be available. Just not going to happen, guys. I wish. And I think it's important for us to accept that reality because we have to find another way. We have to find another way. I honestly do not know what it is. I wish I did, but we have to find some way to wake people up. And I think that it begins by reviewing the scientific papers that we've been doing and shining a light on them, like the EPR experiment that we showed today, which is awesome. One of the coolest EPR experiments I've ever seen. So explain it in a way, demystify it for people. If I can explain that, then, come on, we can do it. Lastly, with God's grace from the Pill Chat says, next time you need to say causality, can you say it with a French accent? Oui, oui, causality. You get the causality? I don't know if that's a French accent, but that's my best I got, guys. Okay, guys, MHU70X, I love you guys. Have a good night. Thank you very much for all donations tonight, guys. We'll be back on Monday and maybe something this weekend as well. We'll see. Peace out, guys. Later. I'm going to play us out with this one.
Infrared eyes, scanning the black, tracking the heat, never turning back. Control 22, a covert gaze. Control 33, in the cosmic maze. Controls in the mix, secrets untold. Silent watchers, brave and bold. In the shadows, they silently glide, protecting our interests, far and wide. As Pierce, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. In the silence of space, they keep their post, shields unseen yet feared the most. With precision and speed, they warn of danger, keeping us safe from the missile's anger. As Beers, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. Controls in the mix, secrets untold, silent watchers, brave and bold. In the shadows, they silently glide, protecting our interests, far and wide. As Beers, sentinel of the night, watching over with infrared sight, alerting us to threats afar, guiding our defenses like a guiding star. As Beers, sentinel of the night, watching over with infrared